السلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 8.5 and it is about systems of inequalities. Let us discuss first linear inequalities in two variables and their solutions. We have seen equations like this in 8.1 straight line ax plus by equals c. We have seen that the graph is a line, and this is called an equation. Now, if you change the symbol equal to greater, less, greater than or equal, less than or equal, then we will have a linear inequality into variables. And these are some examples. 3x minus 5y less than or equal to 15. This is a linear inequality into variables. A solution of this inequality would be an ordered pair. An ordered pair, x and y, would be a solution of this inequality if it satisfies the inequality. If you replace x and y coordinates in the ordered pair by xy in the inequality, and it makes the inequality true statements, then the ordered pair would be a solution. For example, 3, 2, the ordered pair 3, 2 is a solution of this inequality because x is 3, y is 2, 3 plus 2 is 5, greater than 1, true statement. So 3, 2 is a solution of this inequality. Notice that 3, 2 is not the only solution. We have infinitely many solutions of any inequality, okay, of this inequality, x plus y greater than 1. Now, objective 1 is how to graph a linear inequality into variables. This blue line is the graph of the equation x plus y equals to 2. Now, the graph of a linear inequality would be half plane. This half plane is the graph of x plus y greater than 2, and this half plane is the graph of x plus y less than 2. A half plane is the set of all points on one side of a line, as you have seen here in this figure. Now, a half plane is always the graph of a linear inequality with greater than or less than. If it is greater than or equal or less than or equal, then the graph would be half plane and a line. A solid line in this case will be drawn, while a dashed line will be used if the line is not part of the solution set. So, for example, look to this exercise. What about the graph of this inequality? Does it include the line? And the answer is no. The graph includes the line. No, this is false because there is no greater than or equal. There is no equality. It is only greater than, so the line is not included in the solution of this inequality. Now, how to graph linear inequalities into variables? There are 3 steps. First, we replace the inequality symbol with an equal sign. So we change it to an equation and we graph the line that corresponds to this equation. We draw a solid line if the original inequality contains greater than or equal, less than or equal symbol. We draw a dashed line if the original inequality contains a less than or greater than symbol. So for example, to graph this inequality, the first step would be to change this symbol greater than or equal to an equation, to an equality, and then to graph this line. Now, how do we graph a line? We choose 2 points and we connect the 2 points. The best 2 points to choose are always the x-intercepts, the x-intercept and the y-intercept. So to find the x-intercept, I put y 0 and I solve the equation. If you put y 0, you have 2x equals 6, which means x is 3. So this is the first point. To find the y-intercept, I put x 0 If you put x0, you will have negative 3y equals 6. So y is 6 over negative 3, which is negative 2. So I have 3, 0, 1, 2, 3. This is the point 3, 0, 0 and negative 2. And now I draw the line that connects these 2 points. There is equality sign greater than or equal, so I draw a solid line like this. So this is the line 2x minus 3 equals 6. So this is the first step. Now the second step, choose a test point from one of the half planes. Do not choose a point on the line. Substitute the coordinates of the test point into the inequality. So I choose a point from the 2 planes, either from here or from here, but do not choose a point on the line. So 0, 0, for example, is not a point on the line. It is a point on this half plane. If I choose 0, 0 because it's easier to work with. Now, if I replace x by 0, 2 times 0, 0, minus 3 times 0, 0, so 0 minus 0 greater than or equal to 6. Now, is this a true statement? No, this is false. This is not correct. So the answer is not this half plane. The graph of this inequality is not this half plane. It would be this half plane. So this is the answer. This is the graph of this inequality. This half plane is the graph of this inequality, and this is the answer. This is the graph. If a true statement results, shade the half plane containing this test point. If a false statement results, shade the half plane not containing this test point. So we shaded the half plane not containing the point 0, 0 because 0, 0 does not satisfy this inequality. So this is how we graph linear inequalities into variables. Let us solve this exercise. The graph of the linear equation is used to graph the linear inequality. Yeah, true. Because the first step is to change greater to equal and to draw the line. So the first step would be always to draw the line, and then we choose a test point, and then we determine which half plane is the graph of the inequality. Please graph this inequality and this one and this one. Draw the line similarly, find the x-intercept, y-intercept, and then choose a test point, and then determine which half plane is the graph of the inequality. Now, when graphing a linear inequality, we choose a test point, as we said, that lies in one of the half planes, not on the line. You do not choose a test point on the line. That's not good, because if you choose a test point on the line, it will give you equality. It will not give you greater than or less than. So the test point 0, 0 is convenient because it's easy to calculate. So we usually use 0, 0. But if 0, 0 lies on the line, then you cannot choose 0, 0, and you have to choose a different test point. Let us look to this example. How to graph a linear inequality in two variables. First step, change greater than to equal and solve this equation. Now, if you do the same steps, if we try to find the x-intercept and the y-intercept, if we replace x by 0, 0 times negative 2 over 3y would be 0. So I have the point 0, 0. So if you put y 0, you will have x 0. So this is the x-intercept and the y-intercept at the same time. I need another point. So you have to choose now x, another value different than 0. So if I choose x equals to 3, then negative 2 over 3 times 3 would be negative 2, because 3 will be cancelled with 3. So let us graph this straight line. This is the point 0, 0, which lies on the line this time, and I have 3 and -2. This is the second point. Now I can sketch the graph that passes by these 2 points. Notice that it's greater than, it's not greater than or equal. So I'll draw a dashed line. Dashed line like this means it is not in the solution of the inequality. All right. Now I cannot choose 0. I cannot choose 0, 0 as usual, because 0, 0 belongs to the line. It is on the line. So I cannot choose 0, 0. I have to choose another point. Choose any point, either in this half or in this half, but do not choose any point on the line. For example, this point. This point has coordinates 3 and 0. It does not belong to the line. It is on the upper half. So I will select 3, 0. And this is my test point. Put it here in the inequality. So y is 0. So 0 is greater than -2 over 3 times x. X is 3. 3 cancels with 3. And I have 0 greater than -2. Is this a true statement? Yeah,
Yes.
this is true. So where is the answer? The answer is the half plane that contains this point. So this is the answer. This half plane is the graph of this inequality, and the line is not in the solution in this case. So that's the graph of this inequality. So please do this one. And now pay attention to this point. You don't always have to use a test point. Sometimes you know the graph of the inequality, whether it's the upper half plane or the lower half plane, without choosing a test point. When? If the inequality is written like this, y is greater than, it's solved for y is greater than, or y is less than. So if you have inequality y greater than mx plus b or y less than mx plus b, then you don't have to use test points, because if the inequality is y greater than, then shade the half plane above the line. The half plane above the line would be the solution of this inequality. If y is less than, shade the half plane below the line. So look here to this inequality. It is solved for y is greater than. So without choosing a test point, the graph, this is greater than, the graph is the half plane above the line. So that's the graph immediately without choosing a test point. Of course, if you choose a test point, it's not a problem. It's okay. It's correct. But you can just draw the graph quickly. So for example, here, what is the first step? We change greater than to equal. So it's a straight line. And now we solve this straight line. We choose points. Sorry, we choose points to draw the line. So if I choose x to be 0, y would be -1, and this would be the y-intercept. Okay, you put x0, you get the y-intercept. Now, if you put y0 to get the x-intercept, then 2x minus 1 would be 0. So 2x would be 1, or x is half. So half and 0 is the x-intercept. So now I can sketch the graph of this line, 0 and -1, and half and 0. So now we connect these 2 points to draw this line. But notice that this is greater than, so I just draw a dashed line, okay? A dashed line. This is dashed line. All right. Now, where is the graph? This is greater than, it is y, and it is solved for y, and y is greater than. So where is the half plane above the line? It is this one. So this would be the graph of this inequality. You can do that immediately, quickly, without choosing a test point. If you want to check your answer. I'll choose this point 0, 0. 0, 0 does not belong to the line. So if I choose a test point 0, 0, I'll have 0 greater than 2 times 0 minus 1 minus 1. Is this true? Yeah, true. So the solution is the half plane that contains this point 0, 0. So our answer is correct. So whenever you solve for y, it is solved for y. The inequality is solved for y. It's a linear inequality, and it's greater than, the graph would be the half plane above the line. If it is less than, the graph would be the half plane below the line. This is not the only situation in which you don't have to use test points. There are easy inequalities like this: x greater than a, x less than a. If x is greater than a, the line x equals to a, the line x equals to a is the vertical line. This is the line x equals to a. So the graph of the inequality x greater than a would be to the right of this line. So this is the graph of x greater than a. X is less than a would be the yellow region, the graph to the left of the line x equals to a. So it is half plane. The graph of x equal greater than a is the half plane to the right of the line x equals to a. Also, if you consider the inequality y greater than b, so there is only one letter here. Y is not here. There is only x. And here, because x equals to a is a vertical line, and here you have only y. So if you change greater than to equal, you will have a horizontal line, y equals to b. So this is the horizontal line, y equals to b. And now if it is y greater than b, the graph would be the half plane above this line. And if it is y less than b, the graph would be the half plane below the horizontal line, y equals to b. So these are easy half planes or easy inequalities if there is no x or there is no y, there is only one of the variables. So for example, graph each inequality here, y less than or equal to -3. Well, we change it to an equation and we sketch the graph of y equals to -3. Where is y equals -3? It is this horizontal line. It is this horizontal line. And there is equality, so it's a solid line. So this is the line y equals to -3. Now we need to sketch the graph of y less than or equal. Less than or equal, it means this one. So this is the graph of this inequality. Y is less than or equal to -3, and you don't have to choose test points here. Also, x greater than 2, if you change it to an equation, you need to sketch the graph of x equals to 2. And x equals to 2 is a vertical line. And I'll draw a dashed line here because there is no equality. So this is x equals to 2. Now, where would be the graph of x greater than 2? Well, x greater than 2 is just here. It's just to the right of x equals to 2. So this would be the graph of this inequality. Please solve this checkpoint and pay attention. These are the only two cases to not using test points. Test points would be very important, and you have to use them if you have inequalities in this form. Ax plus by greater than c, it is not solved for y, or this one. Then now the graph of this inequality, it could be above or below the line, depending on a and b, the values of a and b. So you have to choose a test point if you have this inequality, ax plus by greater than c or ax plus by less than c. Now the second objective is the graph of a nonlinear inequality in two variables. Nonlinear inequality, so we will have maybe x squared, y squared, we could have log, we could have exponential function, not linear inequality. Remember the linear inequality, ax plus by greater than c or less than c. This is linear, okay? But not linear we will not have x to the power 1 and y to the power 1. How to graph? Similar, the same steps. So first, we change the inequality to an equation. We change it to an equation and we graph this equation. But in this case, the graph of this equation is not going to be a straight line. What is the graph of x squared plus y squared equals to 9? If you remember, the graph of x squared plus y squared equals r squared is a circle with center at the origin. The origin is 0, 0, and radius r. While if you have x minus h squared plus y minus k squared equals r squared, so this is an equation of a circle with center h, k, and radius r, and radius r. All right, so we have x squared plus y squared equals to 9. So the center of this circle is 0, 0, the origin, and the radius is 3. Let us sketch the graph of this circle. 0, 0 is the center, and we go 3 units up, 3 units right, 3 units left, 3 units down, and we sketch the graph of this circle. So accept this graph as a graph of the circle. Okay, this is the graph of the circle x squared plus y squared equals to 9. If there is a less than or equal, it's a solid. We graph a solid line. Okay, a solid line. If there is no equality, we graph a dashed line. Okay, so the circle we graph it dashed, but here there is equality, so we graph a solid line. All right, now x squared plus y squared is less than or equal to 9. Where is the graph? Now I have two regions. Either the graph is inside the circle or outside the circle. So I choose a test point. What is my test point? For example, 0, 0. 0, 0 is always an easy point to choose. It is in one of the regions. You do not choose a point on the circumference, on the circle. No, you choose a point either inside or outside. So 0, 0 is inside. 0 squared plus 0 squared is 0, less than or equal to 9. That's true, that's correct. So this is the graph of this inequality. Inside the circle with the circle itself, this is the graph of x squared plus y squared is less than or equal to 9. What do you think if we ask greater than? Do it at home. Greater than, you will have the region outside the circle. This is again inside, this is outside the circle, but notice the border of the circle itself is dashed, is not included in the solution. Let us solve this question, question 19. First step, as usual, is to choose the less than to equality and then try to solve this equation. What is the graph of this equation? This is a parabola. This is a parabola shifted 1 unit down below. Y equals x squared. We know the graph of y equals x squared. Take it 1 unit down, so it would be here. So what would be the x-intercepts? If you want to find the x-intercepts of this parabola, you put y 0, x squared minus 1 equals to 0, then x squared is 1, and x would be plus or minus 1. So the x-intercepts are 1 and -1, and the vertex is 0, -1. So this is the graph of this parabola. Is it included in the solution? No, there is no equality, so it's a dashed line. So you sketch the graph of the parabola, but dashed line. So now where is the graph of this inequality? Either it is inside the parabola or outside the parabola. So let us choose a test point. For example, 0, 0. This point is inside the parabola. Is the graph inside the parabola? Let us see. 0 less than 0 minus 1. Is 0 less than minus 1? No, that's false. So where is the graph? The graph is outside the parabola, and the parabola itself is not included. It's a dashed line. So this is the graph of this inequality. Please do this one. Okay, Similarly, it's a parabola taken 9 units down. Let us do let us solve question 23. Change it to an equation, y equals 2 to the power x. Now, what is this? This is an exponential function. If you remember the exponential function, if you choose negative 1, 0, 1, then this is half, and this is 1, and this is 2. This is what we studied in chapter 4, if you remember. So there is a horizontal asymptote, and at negative 1, it is half, at 0, it is 1, at 1, it is 2, and the graph is like this. Now, is it dashed or not dashed? It should be dashed because there is no equality. So draw the exponential function as dashed line. Okay, so now where is the graph of y greater than 2 over x? Either it is this part above or this part below the function. So let us choose, for example, the point 0, 0. The point 0, 0 is in this half, in the lower half. If you choose 0, 0, 0 is greater than 2 to the power 0. 2 to the power 0 is 1. Is 0 greater than 1? No, false. So this is not the solution. So where is the solution? The solution is here, this region above above the curve. Okay, that's the solution of this inequality, above the curve. If it is less than, like here, please solve it at home. The solution would be the region below the curve. Let us end our lecture today by graphing this inequality. If we change greater than to equal, we will have log x plus 1 to the base 2. Now, what is the graph of y equals log x to the base 2? We know that the graph of the logarithmic function to the base 2 is just like this. That's the graph. But we will take it 1 unit to the left. So it would be taken 1 unit to the left. So x plus 1, if you make it 0, then x equals to negative 1. That's the vertical asymptote. That's the vertical asymptote. So if you replace x by 0, it will pass by this point. Okay. If you replace x by 0, you will get 0. Log 1 is 0. If you replace x by negative half, okay, you will get log half to the base 2, which is negative 1. And if you replace x by 1, you will get log 2 to the base 2, which is 1. So the graph is like this. This is the graph of the logarithmic function, and it's a solid line because there is equality. Now, where is the graph of the inequality? I choose a point. Now, there is an important point here when you draw logarithmic functions. We know that x should be greater than negative 1 because the domain of this function, is from negative 1 to infinity. So we cannot choose x to be negative 2 or negative 3. If you choose x to be negative 2, this will be not defined. Okay, so you have to choose a point here, and your graph would be here to the right of negative 1. But this region is not included in the graph. So for example, if I choose this point, which is 1 and 0, you cannot choose 0, 0 here because it belongs to the curve. So I'll choose 1, 0. So if I choose 1, 0, put y is 0, greater than or equal to log 1 plus 1, 2 to the base 2. 2 to the base 2 is 1. Is 0 greater than or equal to 1? No, that's false. So this region is not there. So the solution would be this region. This would be the solution above the curve, all the region above the curve. Okay, all of this region. But we do not go to the left of this line. This region is not part of the solution. This is the end of today's lecture. and inshallah next time we continue in section